Hello, everybody. It's a pleasure being here today. This talk is about deep learning and visual tools for analyzing and monitoring integrity risks. How will this presentation be structured? I will start with a short introduction, which provides you with some background on the Integrity Risk Monitor project. Then I will present you with some results from the method on the deep learning classifiers, and afterwards directly move to vision analytics so that you can get an impression of what we are doing there. And we will conclude with the conclusions. First of all, what is business integrity and what do we define as integrity risks? Business integrity can be defined as the adherence to globally recognized ethical standards, both in spirit and letter of the law. And it's something which we would hope that it's granted, but that's definitely not the case. For instance, a recent study of Pricewaterhouse Consulting showed that about 40% of Swiss companies are actually impacted by illegal and unethical behavior. And this number is rather low actually compared to other countries, but still shockingly high. One of the main problems for companies in the field of integrity is that the legal and ethical framework is actually dynamic. That means that they must constantly monitor the state and the changes of the legal framework and adapt to them. And that's actually recommended that they use a proactive approach to prevent integrity risks. And that's the main point of this talk. It's not about a public relation tool where you would try to whitewash what you're doing, but it's really about a serious effort from the companies to prevent integrity risks so that they adhere to standards they are supposed to adhere with. From the technical point of view, what are the main components of the integrity risk monitor of this project? First of all, there's the part in which you are probably most interested in, that are the multilingual text annotation services. We have created services for automatic text classification that basically assign an integrity score, which corresponds to the probability that a document covers integrity topics to each document. Then we use named entity linking for identifying relevant stakeholders and sentiment analysis, as well as other methods from the field of natural language processing. All these annotated documents are then published in a real-time dashboard that is used for monitoring. This can be used for instance, identifying integrity-related issues in these corpora, and also for getting a feeling of whether they are associated or perceived positively. For instance, if a company has taken efforts to prevent corruption within a company, or whether they have perceived negatively if a company has violated such standards. And finally, there's the last, most complicated part that's about analyzing past integrity management gaps in the hope that we can use them to predict and discover existing blind spots, which basically exports time series from the portal and analyzes them. What are the data sources we are using? First of all, we have historical data that is composed of news media coverage on integrity issues, company responsibility reports, plus articles on corruption that have been collected by the Federal Department of Foreign Affairs. Then we have current data that is used for observing, predicting, and validating patterns. This is primarily news media, plus company social responsibility reports. And finally, we are also using linked data as a source for background knowledge for AI, for instance, for the named entity linking. And examples would be DPPD and geonames. The first task that is relevant for all the documents that are analyzed in the portal is to determine whether they are relevant to any of the integrity topics. And for instance, we did an evaluation for the topic of corruption of different classifiers we used for analyzing and determining whether the documents actually are related to the topic of integrity. And we have done this for English and for German. and started with simple baselines that have been basically composed of naive-based support vector machines in different configurations. And you see that especially if we use bag-of-word approaches, the baselines that do not perform that well. It gets considerably better if we use word embeddings, but still state-of-the-art deep learning methods such as BLSTMs and CNNs, which are both noted in literature to be very well suited for text classification, perform quite well. In terms of the word embeddings, it's interesting to note that for German, actually fast text performs better, which is expected because German is also well known for compound words, and fast text supports subtext units, while for English, in most cases, not for the leading system, but for most of the others, actually WordNet performs better. This helps us in identifying integrity documents. The next question is, what do we do if we have them? And the answer is we put them into a portal that can be used by domain experts. The portal supports basically queries, for instance, for the terms corruption, and then automatically determines associations for the result set, which is shown in the middle, plus metadata. You see we have, for instance, here the languages. And the interesting thing is the documents are English and German, actually mixed, but in the portal you only get keywords, etc., in the language of the analyst. In my case, that's now English, because these aggregated metrics are actually translated in real time. You also see the fraction of negative and positive coverage and the distribution, the geographical distribution across the world, plus a tag cloud that is specific to the search query, plus a keyword graph for analyzing it. What can we do with this? For instance, we can analyze integrity events. We have done this for this presentation for a use case of the 1MDB bank, which has been a Swiss bank that has been involved in a corruption case. And a very simple thing, which is still interesting, you can do is to present the number of mentions, positive and negatives over time. The first question you now may ask is, for instance, why is there a peak? And that can easily be done by just clicking on the peak, which will provide you with a pop-up which supports you in drill down analysis. For instance, you can restrict the search query to exactly these, in this case, 5 documents that are responsible for this peak. And you will get associations which show you what are basically what the content of these documents might be. The same can be used in conjunction with keyword graphs, which show you basically how the important concepts of the domain are connected to each other and what are the important concepts. And for instance, you might be surprised that Goldman Sachs is mentioned here in this keyword graph. Again, based on a drill down analysis, you can quickly figure out why Goldman Sachs is actually mentioned. You can also take a look at relation graphs that show you basically important concepts like 1MDB, Goldman Sachs, and how they relate to people that have been identified within this corpus. And for instance, you might question yourself why this person has been mentioned, and you will see, okay, he has been a politician in Malaysia who has been involved in this scandal. Or why Goldman Sachs is relevant. Again, you can basically drill down to the singular article which shows you this, which again is very helpful for domain experts. The same is true for the Swiss, for the geographic distribution. For instance, you might be interested, why is Switzerland here involved and what's the role of Ticino? And again, by just clicking on the data point, you will get information on why that's the case, and you can narrow it down to the single document. And the same is true for persons, and this is actually a case which also shows how important these drill down analyses are. For instance, Paolo Bernasconi has been mentioned in conjunction with this case, but you see this has been a negative mention. And you might now ask yourself the question, why is this the case? because he actually has been a federal prosecutor. And if you then take a look at the article, you will see that he actually gave an interview covering this case. And the interview has been identified by sentiment analysis as negative. And that's the reason why he is actually mentioned negatively here. In conclusion, the Integrity Risk Monitor aims at supporting companies and experts from business ethics in monitoring integrity topics and analyzing past integrity events as we have done it here. The system uses deep learning to automatically identify relevant events, uses named entity linking for annotating named entities, and sentiment analysis so that you can distinguish positive and negative coverage. The annotated documents are exposed on a visual dashboard that supports advanced real-time analytics and drill-down analytics, and especially the last point, the drill-down analysis, are very important to interpret events correctly. Okay, thanks for your attention. I'm looking forward to your questions. Thanks a lot.